Now, a car can move with acceleration 3a and deceleration 5a. Find in terms of k, the time taken to cover a distance of 90 ak squared from rest to rest. Now, subject to the speed limit of 15 ak. This has velocity time graph written all over. Why does it have velocity time graph written all over? Can anybody tell me?
Acceleration, deceleration.
One object has a acceleration part, a constant velocity part, more than likely, and a deceleration part. Three separate parts, one object. Massive indication that you're doing a velocity time graph. Okay? Most times in Leaving Cert they'll actually tell you to draw it as like 5-10 marks worth, but today this question didn't say a word about it. So we're going to be subjected to 15 ak speed limit. So that's your velocity, that's your time. Which time is longer, the time spent in accelerating or the time spent decelerating? Because acceleration isn't as big as the deceleration. You're going to be spending more time accelerating than decelerating. So when you draw your diagram, make sure that it's longer going this way, and then your deceleration part is more abrupt, drops down a bit faster. Okay? Don't have to necessarily do it to scale, but you get the basic concept there. Now, the speed limit is 15 ak. That means that the height of every object in here is 15 ak. Now, does it say that we start from rest? It does. The reason we start from rest, it says it there. That means I'm allowed to start here. There. Okay. Now, if it didn't say specify rest, what would I have to do? If it didn't specify rest, what would I have to do? I'd have to start up here and then go up to meet the speed limit, and your first area would have a triangle with a rectangle underneath. But that's not the case, because it specifies that we start from rest. But if you didn't start from rest, that's exactly what you do. Okay. So, what can we say about, we need times here, 3 times, T1, T2, T3. Now, deceleration 3a. The acceleration is what I'm not using at the moment. Okay, that's what I need to learn how to use. What do we know about tan A? Or sorry, tan x. Tan of this angle is what? Acceleration is tan x, okay? So, everybody know that from before? So, acceleration equals tan x, and tan x is, what is it? 15 ak over t1. Okay? Now, what does that mean in regards 15 ak all over T1 is equal to 3a. Now, I say we isolate T1 because the reason why I'm choosing to isolate T1 is it says find in terms of k. Alright, so that means I should isolate T1 and have everything in terms of k where possible. So T1 equals, it's going to be 15 ak all over 3a. T1 therefore equals 5k. Everybody happy with that? Same trick for T2 or T3. We'll call that tan y. Tan y equals 15 ak over T3. And that in turn equals 5a. Do you notice the sign isn't relevant for this? It doesn't matter. It's the magnitude of the deceleration. Technically, that's minus 5a because it's a deceleration, but it doesn't matter when you're doing the angles. It's just the magnitude you want. Okay, so we're going to reverse up T3. Going to divide 15ak by 5a. And what we get there is that T3 equals 3k. Now, okay, we're nearly in business now. Can anybody tell me the next step? Anybody familiar with the next step? What's the one thing we don't have at the moment? We don't have T2. But what do we have? We know that the area of the triangle plus the area of the rectangle plus the area of the other triangle has to equal what? 98k squared. The area of all three objects added together is always the distance set in stone. Okay? So, what I need to concentrate primarily on here is, will somebody just remember T1 is 5k, T3 is 3k? Actually, I'll do it now. So, you're 5k and you're 3k. Yeah, we just need to rub the rest of it out. And once we've done that, what we're going to find out is what to do here. So, okay, add them together. So the area of section A, section B, and section C. So the area of A is a half base by height, which is a half 5k by 15 ak. Area of section 2 is 15 ak multiplied by T2. Third section is area C, and it is a half 3k times 15 ak. Alright, that's 37.5 ak squared to my knowledge, a half of 75. The next one's still 15 ak T2. The third section is going to be 22.5 ak squared. Now 22.5 plus 37.5, 60. 60 ak squared plus 15 ak T2. And what does all that have to equal? 90 ak squared, because that's the entire distance. Now once we have that determined, what we've got to do next is figure out what area B is equal to. So area B is 15 ak T2. It equals 30 ak squared. Divide 15 ak into it and we're going to get T2 equals 2k. So T2 is 2k. Okay, so the time taken go rest to rest. Anybody know? Or sorry, from rest with speed limit and back to rest again. 5k plus 2k plus 3k, 10k. Right, so 10k. Any questions on that one? Okay, you probably need to do it again later on your own. Again, just get the feel of it. Okay. Now, what we're going to do next is subject to no speed limit. When you have no speed limit, you're looking at two triangles, because you go all the way up. That's your speed increasing. We're going to call our new speed limit V. We don't know what it is yet. And then we're going to drop down more abruptly because the deceleration is faster. So that's V, and that's T1 and T2. Now, anybody remember the ratio of T1 to T2? Because T1 and T2 are both happening from the same speed limit. So 0 to V or V to 0, it's still the same drop or the same uplift, okay, in speed. So there's a ratio. Does anybody know the ratio? If T1 is the time spent during accelerating and T2 is the time spent during deceleration, what's T1 and T2 the same thing as? Deceleration 2, acceleration, which is going to be 5:3. We're expecting T1 to be the longer time, aren't we? Because it has a slower acceleration. So it takes longer to get up to this maximum value. because it's only 3a compared to the decelerations 5a. Deceleration does it quicker. Okay, so that's the ratio of T2 is to T1. Okay, so what can I call them then? I can call one of them 5t and the other one 3t. Now, if you're not comfortable with doing it that way, there's another way around that. Okay, you could also use your angles x and y, and what you could say is acceleration equals tan x. Tan x equals phi over t1. Therefore, phi over t1 is the same thing as 3a. So t1 equals phi over 3a. You could have also done deceleration equals tan y. Tan y is phi over t2. Opposite over adjacent. And that equals phi over 5a. Oh, sorry, no, just equals 5a. Therefore, T2 equals phi over 5a. Then, once you did that, what you could have done next was this. You could have said, let's get rid of that for a second. What you could have said next was that T2 divided by T1. T1 divided by T2 is phi over 3a divided by phi over 5a. The phi's cancel, and what we're going to be left with is 5a all over 3a equals T1 over T2. Cancel the a's, and then you would have been left with 3T1 equals 5T2. Wait a second. Yeah, I had my one the wrong way around, didn't I? The first one. 3T1 equals 5T2. Okay. What happens next is when you put this into ratio form. Ratio, remember, is a fraction. Okay. So when you put it into fraction mode, what you get here is that T2 divided by T1 is the same ratio as, is that right? T2 divided by T1, yeah, bring the T1 down, bring the 5 down, and you get T2 over T1 is 3 over 5, okay? So that's what we already knew. We already knew that 3 times whatever T1 is equals 5 times whatever T2 is. T1 is the bigger object, is the longer time, okay? So when we equate them to having the same time as each other, this one is going to have 5 times a certain amount of time, and this one's going to be 3 times the same unit of time. 3t is still the smaller number here, because it's a smaller amount of time, while 5t is the larger amount of time. Now, what we're stuck with doing next is we got to do the we have to do the area formula. Okay, so we're going to have to do a half area A plus area B equals 90 squared. Okay, and we should also find out the velocity, the maximum velocity in terms of. We had to find out the velocity in terms of A as well. So we're going to do next. So I'll explain my steps here, okay? So the first step here would be, the first thing that will come to my mind is using the area formula. Okay, so area A and area B. Now, with area A, what we can say is that it's a half base times height. So it's going to be a half 5t times phi, and then the other one's going to be a half 3t times phi, and all of that equals 90 squared. Problem here is we have 2 variables. We have the variable v and the variable t. It's not enough equations to get out both variables. We need another equation, and we need to figure out where to get it from. So if I go back to the very beginning, and if I use phi equals u plus at, so phi equals u plus at, it starts from rest, so u equals 0. Our a is 3a. Our time is 5t, and that equals v. Therefore, phi equals 15 AT. Now, the a's will cancel. See the way there's an a on the other side? 90 ak squared. If I introduce a in for this, the a should cancel, so it shouldn't be a big deal whatsoever. So it's going to be a half 5t times 15 AT plus a half 3t times 15 AT again equals 90 AK squared. Now, first thing I'm going to do is get rid of those a's. Everything's been multiplied by a, so they can disappear. Next, 5 times 15 is 75. 75 divided by 2. 37.5 t squared plus 22.5 t squared equals 90 k squared. 60 t squared equals 90 k squared. And then what we're going to have next is t squared equals 3 over 2 k squared. So I'm going to square root the top and the bottom, and what do we get there? T is going to be the square root of 3 over 2 k. Now that's not the answer to the question. What is the answer to the question? Find the time taken to cover a distance 98k squared from rest to rest. Rest to rest would mean 5t plus 3t, 8t. So multiply this number here by 8. So what's root 3 over 2 multiplied by 8? That's all in the square root sign. Anybody know?
4 root 6.
4 root?
6.
Okay, so that's the answer I got, 4 root 6. Yeah. So t equals 4 root 6k. Alright guys. So, this question here, if you read the language, a particle moving in a straight line with constant acceleration. Constant acceleration means a equals a. It's the same for all intervals. It's the same for any part in this question. Passes through points P, Q and R. In fact, there's 3 different points, means we're looking at an interval question, okay? Where Q is the midpoint of PR. So what you're going to have is P. Now it doesn't specify it's at rest at P, so it's already moving, okay? So P, Q and R. So look, we can just call that S and S, and the distance from P to R, 2S. No worries there. Okay? Or we can just we'll call it X. X might be easier, so we don't have to send letter twice. So let's call them X, okay? Now, it says the speed at P. The speed at P is 7u, and the speed at speed at P is u, and the speed at R is 7u, respectively. Find the speed at Q in terms of u. Okay, so we're going to set up u fast for both systems. So u fast this time is going to be for PQ and PR. What is the goal of this question? Which letter in which data set are we looking to find? Anybody know? Which letter in which data set is the goal of the question?
V and PQ.
We're looking to find what phi is in PQ. Because your end velocity in the interval PQ is your starting velocity in the interval QR. Okay, so that's what you're looking to do. Now, what do we know? That's U, that's U, that's 7U, that's A, that's 2x, that's x, that's also A, and time, we haven't got a clue what the times are about. Now, I've already ruled out s equals ut plus a half at squared. Why did I rule that out? Ut plus a half at squared. Too many variables by the looks of it. We haven't got any idea about times at the moment, so let's stay away from them. I'm thinking v squared equals u squared plus 2as is the best one to use. So v squared equals u squared plus 2as. We'll start off with the one. Which one has more data? PR is the one that has more data for us, okay, has more information. So, we're going to get is p squared is going to be 7u squared equals u squared plus 2as, so it's going to be plus 2ax. Now, 49u squared for this, bring over the other u squared, take it away, 48u squared equals 2ax. Now,
it should be 2 by 2a.
Oh, sorry, 2a by 2x, excuse me, so it's 4ax, good call, 4ax. So, the question here is, which letter do we get on its own? A and x, or do we leave it as ax? If we're going to use the same formula again, we're going to have ax there, aren't we? So we might as well just leave it on its own. So I'll just do 12u squared equals ax. If you did decide to get one of the letters on its own, it's a quick one to do, and you'll still get this. You'll still get it and put the same thing if you didn't see that. Now we're going to go to the second set of information. Once again, we're going to have our phi squared, which is our goal of our question, equals u squared plus. This time it's 2ax, and we know that ax equals 12u squared. So phi squared is going to be equal to u squared plus 24u squared, because it's 2 times 12u squared. Phi squared equals 25u squared. Phi therefore equals 5u. So 5u for that. Are you happy enough with that? Now, show that the time taken to go from PQ is twice the time taken to go from Q to R. P to Q is twice the time taken to go from Q to R. Okay. So, this is the odd one where I'm actually going to have to isolate QR. Or do I? I technically don't, but it makes sense to do it. I could do this two ways, okay? First way is I get the time in terms of U for PQ. I get the time taken in terms of U for PR. And what's PR minus PQ? The time taken for QR. I could get it that way, but there's no need to be so fancy about it. So what we're going to do is we'll just get rid of that data set there for a minute, and leave it there. Up. So 5u. So lads, we're going to do QR this time. For QR, what's this initial velocity? We just got it a second ago. 5u. You're going 5u at the end of PQ, therefore you're going 5u at the start of QR. What's our end velocity for this one? 7u. Because when you cross R, you're on 7u. Our A value is still the same. What's our S value? Midpoint. If that's X, that one is also X. And then T is the whole point of the question. We want to find out what T That's called T1 and T2 are. Okay? So, and 12u, we need this piece of information here. This piece of information might come in handy. 12u squared equals ax. I think it will anyway. Phi equals u plus at. Yeah, actually lads, we don't need it. Phi equals u plus at for both of them. Now, phi equals u plus at. So, time. The most basic time equation we have is phi equals u plus at. Phi equals u plus at. If we isolate t, we get phi minus u equals at. T therefore equals phi minus u all over a. Now, what we're going to have for PQ is that T1 equals 5u minus u all over a. T1 equals 4u over a. By the same reckoning, T2 is 7u minus 5u all over a, which is 2u over a. Now, it might be just worth dividing T1 by T2 and really spelling out home that like T1 divided by T2 is 4u over a, 2u over a, T1 divided by T2 equals 2. And now you've proven it. Okay? In my opinion, it wouldn't be enough just to stop at the two of these. You'd have to really spell it out at the end. Okay, one more for the road. Question 6. Okay, have a quick read and come up with a way of doing it. So, in this question here, a particle starting with initial speed u with uniform acceleration, show that the distance travelled during the nth second will be u plus am minus a half n. Distance travelled during the nth second would mean that I'd have to find out how much distance to travel, called Sn, in n seconds, and then if I find out the distance of Sn minus 1, where n minus 1 is 1 second shorter than n seconds, and then if I find out the difference between this one and this one here, then I find out how much distance did you cover in the n seconds. It's the equivalent to if I said I travelled 100 meters in 5 seconds, and then on another question I got 80 meters in 4 seconds, then I can say, well, in the 4th to 5th second, or in the 4th second, I travelled 100 minus 80, which is 20. Now, there is one problem here actually. Okay? Now there is a problem with my system. Or is there? Sorry, the problem with my system. I'm using S of n minus 1. So I think I should be using seconds. T, and then use n, and then we want to find out how far we travel during the nth second. Okay. 0 to 1 is the 1st second, 2 to 3 is the 3rd second, therefore n minus 1 to n is the nth seconds. So if I get the difference of S of n minus 1 and Sn, I find the distance travelled in the nth seconds only. So that's the distance in the nth second only. Okay? So, therefore, what we're going to do is two different data sets. We're going to do Sn and Sn minus 1. So UVAST, UAST. They both start off with U, they both have an A, we need to find out what Sn is. We need to find out what Sn minus 1 is. A, U. Now, time. What's the time for this one? N seconds. The time for this one? N minus 1 seconds. Let's find out both distances using ut plus a half at squared. So, S of n is going to be un plus a half an squared. S of n minus 1, which is the more difficult one, is going to be u times n minus 1 plus a half. Now, I'm just going to find out what t squared is up here. Just square n minus 1 squared, and then you get n squared minus 2n plus 1. Okay? A half a times n squared minus 2n plus 1. Which is going to be un minus u plus a half an squared minus an plus a half a. Now, what we have next is the task of taking Sn minus 1 away from Sn. So, Sn minus Sn minus 1. Is there anything that will cancel straight away? The UNs will cancel when I start taking them away. The half an squared will cancel. Now, everything that's in here, I'll just change the sign because I'm technically taking it away. So I'm going to get u plus an minus a half a, which is exactly what I'm looking for. Now, this is using this formula here. We're going to move on to part B. Okay, this is what we call a general formula. It will work for anything we want. If I replace in n equals 5, what does that do for me? N equals 5 will turn that into S5 minus S4, which will give me the distance travelled in the 5th second of motion. Any n value I sub in here will work. Okay? So, what we're going to do next is we're going to use the data from the next question on, and we're going to use this formula more than likely. Travelled 17 metres in the 2nd second of motion, and 47 in the 7th second of motion. How far will it go in the 10th second of motion? Well, what we can say is this. The formula for the distance travelled in any second of motion is u plus an minus a half a. Now, it travelled 70 metres when n equals 2. Remember, n is technically the time value. Okay? So 17 equals u plus a times 2, 2a minus a half a. Therefore, we're going to get 17 equals u plus 3 over 2a multiplied by 2. 34 equals 2u plus 3a. We can see that we have half a simultaneous equation here. Next, we're going to use the same data here. 47 equals 7 seconds. So it's going to be u plus 7a. 8 times 7 this time. And then minus a half a. Once again, multiply everything by 2. We're going to get 94 equals 2u plus 14a minus a. 94 equals 2u plus 13a. You solve these as a simultaneous equation. Am I alright just to put down the answer of the simultaneous equation? Okay, so when you solve these as a simultaneous equation, does anybody see it? We solve these as a simultaneous equation. I'm going to get a equals 6 and n or u equals 8. So that will be 78 plus 16, which gives me 94. That works out perfect. Okay. Now we know that a equals 6 and u equals 8. So a equals 6, u equals 8 when you solve the simultaneous equation here. Alright. Now, How far will it go in its 10 second of motion? Well, what we know now is that the formula, A is 6, U is 8. 1 second. A equals 6, U equals 8. So, what we know about this one is that our formula now becomes 8 plus 6n minus a half of 6, a half of 6 being 3. So our formula for distance travelled in any second of the motion now comes 5 plus 6n. So if I want to find out how far it travels in the 10th second of motion, I just need to replace in 10. So S10, the distance travelled in your 10th second of motion, is going to be 5 plus 6 times 0, which is 65 metres. Okay? The general formula, we want the nth second of motion. How far will it go is what we're looking to find. In the nth second of motion. Oh yeah, we already have that down. 6n plus 5. So Sn is 5 plus 6n. It's already written for the nth second. Finally, during which 2 consecutive seconds will it cover 256? Well, we don't know. So let's use the general term Sn minus Sn minus 1. The distance you covered in all n seconds minus the distance the second before that. It's the same thing as S100 minus S99 is the distance you covered in your 100th second. So we already have the formula, and so do you want me to travel? Oh, consecutive seconds, lads, excuse me. Consecutive seconds is different. Consecutive seconds will be currently our formula that I'm calling Sn. This formula Sn gives me the distance covered in any 1 second I want. If I replace n with 100, what does it tell me? The distance covered in the 99th to the 100th seconds. Now, it says consecutive seconds. What does that mean? Consecutive seconds. It means one comes after the other. So, for example, if I said S99 plus S100, that's actually the amount of distance covered in 2 seconds. The 99th second followed by the 100th second. So what I have to do is I'm going to find out what Sn and Sn plus 1 is. Sn plus 1 is going to be 6 times n plus 1. It's going to be 5 plus 6n plus 6. It's going to be 11 plus 6n. Now I have to find these 2 seconds added together. It's the same thing as S99 and S100 is equal to 256. So 11 plus 6n plus 5 plus 6n equals 256. Therefore we're going to get 12n plus 16 equals 256. 12n equals 240. N equals 20. So this means that it was covered in the 20th and 21st seconds. You covered 256 meters. Okay guys,